Hello guys, today we're going to prove this expression that Laplace transform of t to the power of n is n factorial over x to the power of n plus 1. And we recall how the Laplace operator works on any function. But then we'll say let t to the power of n, we could just call this in. And in the same manner, t to the power of n minus 1, we could just call this n minus 1 and so on, just to make our work easier. Alright, so with that being said, so a Laplace transform of t to the power of n, we're going to write it for the last time, which is just and this is simply the integral from 0 to infinity. What we'll have here, t to the power of n dot exponential negative st dot t. Alright, and if you remember integration by parts, we have u the v is equals to uv minus integral v du. Alright guys, so let our u be t to the power of n, and this simply implies that our du is going to give us n t to the power of n minus 1 the t, and let the v be equals to exponential negative st, which implies that our v will just be exponential negative st over negative x. And if we now apply this, we have that our in, which is Laplace transform of t to the power of n, is simply going to give us uv, which is t to the power of n, that's exponential negative st over negative x. Apply the limits to it, minus the integral of v du, and our v here is goes from 0 to infinity, exponential negative st over negative x. That's the u is n t to the power of negative n minus 1 the t. Alright, so let's try and simplify this by solving this term. Okay, and this is simply, if you take the limits for when t is infinity, infinity to the power of n is infinity, dot e to the power of negative st, and t is infinity, s is positive, so this is going to be negative infinity all over negative x. Okay, minus when t is 0, 0 to the power of n is 0, times whatever is going to multiply is going to give us 0. 0 times any term is 0, so this is just 0. But we know that e to the power of negative infinity, this is also equals to 0. 0 times infinity is 0, so 0 minus 0 is just 0. So this term here is 0. So all we are concerned about is the second term here. Alright, so which implies that our in is equals to negative integral from 0 to infinity of e exponential negative st over negative x dot n t to the power of n minus 1 the t. Alright, and this is same as we can pull out this negative x and pull out n. They are not dependent on t, and this will give us n over x. Negative will cancel negative, 0 to infinity, we can put the t forward, tn minus 1 e to the power of negative st the t. And if you look at this whole thing is just the Laplace transform of t to the power of n minus 1, which we can call n minus 1. And you multiply n over x. So which implies that our in is just n over x n minus 1. Alright, so looking at this, so if we'll say let n be equals to n minus 1, this our expression here is just going to give us n minus 1 will give us n minus 1 all over x n minus 2. and that follows suit for I n minus 2. This is going to give us n minus 2 over x I n minus 3. So with this, we can easily write a series for this term. So our I n was going to give us n over x, n minus 1 over x, then I n minus 2, which is same as n over x, n minus 1 over x, n minus 2 over x, I n minus 3. So to write a complete series for this, we're going to have something like n over x dot n minus 1 over x dot n minus 2 over x dot n minus 3 over x dot n minus 1 over x I naught. Alright guys, and if you just pick this is going to give us in is going to give us n into n minus 1, n minus 2, n minus 3, n minus 4, Where exactly is this term here? So we have n minus 1, and this is just gonna give us 1. So this is going down to 1 all over x n times multiplied by your I naught. So this will simply give us n factorial all over x to the power of n I naught. And where exactly is I naught? I naught from the earlier definition is just the Laplace transform of t to the power of 0, which is Laplace transform of 1, which is 1 over x. So if we replace I naught with 1 over x here, we have n factorial over x to the power of n times 1 over x, which will give you n factorial all over xn plus 1. And that proves our case. So this simply implies that our in, which is the Laplace transform of t to the n, is simply n factorial all over xn plus 1. And this is very, very important and very vital in solving your Laplace transforms. Thanks guys, and remember to subscribe to my channel. If you have any questions, please drop it in the comments. I'll be very willing to respond and help you out any way I can.